Hey everybody, so this is going to be the intro to assignment 6, which will be a Grasshopper Rhino introduction. For this assignment, we're going to do things a little bit differently. There's less of a creative component because we're just going to try to accomplish a series of exercises that I've laid out. Each of these exercises will have its own YouTube video that you can follow along with to sort of make it as easy as possible. And really all you have to do is just follow along on each step and you should be able to complete the assignment. This does not involve much sort of exploration. It's simply just a following exercise. And hopefully through that, you'll get to see a couple different ways that you can use Grasshopper to start to generate either patterns or forms or structures or other things, and get an idea of how it actually comes together. We'll be doing a more advanced Grasshopper assignment in a little bit, but this will be our introduction. So we're going to be creating 4 different things. The first is just a very simple archway between 2 curves, something like a pavilion, maybe of some kind of structural pavilion, maybe. The second, we're going to create a 2D pattern generator. This is something you might do, say, if you were doing a screen wall in a project. So we'll be doing that on a 4x8 panel, which is a common material dimension that you can get, say, laser cut professionally. And I've had 4x8, say, sheets of metal that are cut down to specific patterns. So it's a very realistic use of the Grasshopper software. The next, we'll be creating a multi-story skyscraper that rotates and generates structure and a few other things all very quickly. And then lastly, we'll be doing a space frame structure, which is what you see on the screen in front of you. There will be an optional 5th exercise that is just optional. You don't have to do it. It won't affect your grade either way, but it's a little bit more complicated, so I didn't want to make it a requirement. But if you guys are interested in this sort of thing, it's a good exercise to go through. So what makes also this assignment a little bit different is because we're not aiming for specific creative output, I'm just going to ask for a little bit different submission this time around. So first of all, each time you complete one of the assignments, one of the exercises, which you'll do just by following the video and doing the same steps I do, I'd like you to take a screen capture of your screen that looks similar to what you see at the top of the assignment sheet, where you have the Rhino with a full view of whatever it is you're working on and the Grasshopper definition next to it. And this is easy to set up. If you're on a Mac, the command Shift-Command-3 will automatically just take a screen capture of your entire screen. On Windows, you can either use the snipping tool, which is a program, or Snip and Sketch, which can be accessed through Windows key Shift-S and saved to your Photos folder. Along with that, I'm also going to ask that everyone submit a single Rhino file and single Grasshopper definition that you completed your work in. And then I have some naming conventions here at the bottom, which I'll just go down to real quick. And essentially it is, since there are 4 assignments, potentially 5 if you do the optional, with each one of those full screen captures, you just want to combine them into a single PDF. Acrobat can do this very easily for you. For the Rhino model, you just want to save your last name, first name, 005 model.3dm. For the screen capture PDF, it's last name, first name, 005 underscore screen.pdf, and a Grasshopper definition, last name, first name, 005 definition.gh, which is the file type for Grasshopper. Everything is due at the beginning of class, October 13th. And again, we're having a slightly different submission format for this, in part just to make sure that everyone completes the work. So we'll have a couple ways to validate that, both through the screen capture and the Rhino file and Grasshopper definition. So now we're going to go do a little bit of an intro to Grasshopper. So first of all, these are the sort of things that we're going to be creating. So at the far left here, we have a space frame structure, which is a kind of unique looking thing that essentially would be a sort of somewhat realistic structural form that could make for a amorphic planar roof object. This is actually the optional component here, which is a script that will essentially panelize a surface in Rhino and create these little openings for you. The openings could also be individually controlled so that they're opener in one area and closer and more closed in another. So here we have our sort of Grasshopper skyscraper, which has a structure, some floor plates, columns, and then some glass as part of it. So 3 different components there. As I mentioned, the 2D pattern. So this is a 4x8 sheet that has circles cut out of it. So again, this might be some kind of screen wall that you would use in a project, where each one of these could be unique, or this could be copied repeatedly and made into a wall of some sort. And the final, and actually the first one we'll cover, is really going to be the archway that's essentially connecting 2 different curves that you draw out and then creating an archway between them. So I'll go over how to cover these again in a separate video for each one, but I'm just going to go over sort of the basics of Grasshopper now. So I'm going to make this guy full screen. So in order to start Grasshopper in Rhino, just type in the command Grasshopper. As long as you're using the most recent version on both Mac and PC, this should work for you. Older versions of the Mac don't have it. So if you're running, I think it's Rhino 5 on Mac, which none of you should be, that will not have Grasshopper, and you need to get a trial version of the newer version to get that to work. But the current version should work fine. All you have to do is type in Grasshopper. And fortunately, it should look the same for both Mac and PC. So mine will look slightly different because I have several extra plugins that I use for more advanced scripting. One of the big benefits of Grasshopper is there are a ton of plugins that you can get that give you a lot of extra functionality that you could potentially write yourself, but a lot of it is already done for you. For this assignment, though, I'm only going to be using the default Grasshopper components. So Grasshopper is essentially a visual scripting language. And what that means is you've probably seen coders, say in Silicon Valley or something like that, coding in C# or BASIC or one of the coding languages you've probably heard of. A visual scripting language attempts to do something similar, but instead of having to write out lines of code and understand what each one of those lines means and use the proper syntax and all those sort of things, a visual language gives you a series of nodes, which you see here in front of you, these little boxes that you can just drag into your little panel here, just an infinitely large panel that you can spread out on. And each one of these does a very specific thing. We're probably only going to be covering, even among the default ones, 2 or 3% of all that it can do. Probably less, honestly, but we'll cover a few of the components. So up here, we have params, which are essentially your basic components, basic geometry, things like lines, curves, dots, panels. I'll go over all these a little bit more detail as we use them. The next are the math equations. So if you happen to be someone who enjoys math or say took calculus and really enjoyed it in high school, or trigonometry or any of those things, a lot of what Grasshopper does will probably come a little bit easier for you. It's a very ruthlessly logical program. Every step is completely logical because it is a scripting language. So if you can start to understand the sort of machine logic behind a scripting language, which is very similar to the sort of mathematical logic you might have used in calculus or something else, it tends to be a little bit easier to understand. You can actually use multiple scripting languages inside of this. So if you are more familiar with doing traditional text-based scripting, you can use C#, Python, or VB script, which is specific to Rhino. But we're not going to do any of that. We're going to keep it fairly simple. Then we have this next panel of sets. So this is how you manipulate sets of data. So much of Rhino, much of Grasshopper, I should say, is really manipulating sets of data. So this thing you see here is called a panel, and it just shows what is in each one of these nodes. So this node has a list, as you see here, and this list has a series of sublists within it. So this list here has 3 different data points. Each one of these data points is actually a point in space. I know this just because I can recognize that it has 3 different numbers. And those are the coordinate points. You don't need to know all of this. I'm just kind of going through the extra detail right now. Next, we have vector. Vectors are essentially movement. So a vector is a line that also has an amplitude to it that implies a movement in a direction. Again, we'll cover that more specifically as we use them. Curves, so these are probably something you'll be more familiar with. And of course, under each one of these panels, there's also subpanels. So, we have curve generation, where we can generate polylines or Bezier curves or interpolated curves. We can also do analysis. So we can figure out how long a curve is. We can subdivide a curve. We can find a specific point on it. We can determine whether points are within a closed curve or outside of it. Lots of different things. Surfaces, lots of similar things here. So we can analyze, we can create surfaces, we can generate primitives such as cylinders, cones, spheres, the sort of basic geometries of 3D software, as well as some other stuff. Again, we'll go over more in specific detail. Meshes are something we haven't really messed with terribly much. It is the other form of common geometry that is some modeling softwares use. Rhino tends to use NURBS software, which is a curve-defined, vector-defined surfaces, whereas meshes are point-defined surfaces. They tend to be a little bit less complex, but their lack of complexity also allows them to do some rather interesting things. I don't think we'll be covering any of this initially, but we may cover it later on in the more advanced software, or more advanced Grasshopper intro. Of course, we have intersections, so determining whether or not some lines intersect with each other, or your basic Boolean operations that you might be familiar with from Rhino. Essentially, every command that exists in Rhino, there's probably a parallel that can exist in Grasshopper. Oftentimes they have the same name, but not always. Transform, these are transformations, so either manipulations of a geometry, morphing it, for example, or other things. And display, I believe, is the last of the default ones, and these just allow you to display data or tags or colors. The others that I have here are things that might be interesting to look into if you're really interested in Grasshopper. So Weaverbird is an interesting one that gives you a lot of sort of amorphic geometric generation. So if you're interested in sort of those bizarre blob texture forms and panelized crazy shapes, Weaverbird is your best bet. My personal favorite is Kangaroo, which is a physics simulator. So not only can you do structural loads, but you can also do things like if you wanted to drape a cloth across something and watch as that cloth falls through space and then lands on an object and then deforms perfectly to that object. So there's some really interesting things that you can do there, as well as with tensile structures. And this is something we may cover at a later time too, because I think Grasshoppers or Kangaroo specifically is a really fascinating add-on. And then I have some extras. So some of this I actually already showed in one of my optional demos on how I create site plans, but I have what's called Meerkat in here, which allows me to create those site plans that we've distributed for Studio. There's also Elk, which is a similar software. Again, I'm not planning on covering these for that. I'm just mentioning because I have them. So, as I said, this is a node-based scripting language, and essentially you connect nodes together to do things. So looking here, and again, I'll cover this one more specifically as we go through and create this, but this takes a curve, it subdivides that curve, and then uses the subdivision, which creates a series of points to create new lines, and then evaluates those lines, finds a central point, moves it. It does a whole bunch of things. Essentially, it does a series of operations. One thing that's good to note, though, about Grasshopper and the way it functions is everything here is live. So I'm just going to zoom in here and we can see what I mean by that. So right now I have all these things hidden, but I'll make them viewable for us. Oops, that's not right. So this is what that script is currently looking like. And what I mean by it is live is that, so we have these sort of input curves, which are actually curves that I drew out. They are being subdivided, but that subdivision is a live subdivision. So I can adjust how many times I want it subdivided. And that affects everything down the line. So as I start creating lines that connect them and ultimately weave them together and create these arches, which is going to be our sort of output for this assignment, everything is flexible from the very beginning to the very end. So how I subdivide it, and again, this is a very simple version, but I have some movement here that can adjust that arch. Everything is controlled through these little panels. So I can make it go flat or very high. But that also means that this can get fairly complex, and also can, if you're not very careful, can really slow down your computer, or you could create infinite amount of data really quickly that can make your computer just pretty much instantly crash. We're going to try to avoid those, of course, and I'll try to show you the pitfalls and how to avoid those particular situations. So all these are going to be fairly simple, but it is something to be aware of. Just because you've added a line component that's connecting the series of dots, these dots still exist. Even if you can't see them, they're still there. In fact, so there's a couple different viewing modes here. So right now I have what I believe is probably the default, where this button here is selected and the green one is not. And what that'll do is it will show everything that you're working on that isn't set to be hidden. If you click the guy next to it, it will only, this little green thing, it'll only show you whatever you click on. So you only get the visual feedback of one thing at a time. And this is usually how I end up working because it's a little easier to keep track. Sometimes I will do leave everything on and hide things as I go. So in order to hide things, and I'll just go through a couple of the simple commands here. So if I have a bunch of these nodes selected, if I right click not on a node but in a space around them, I could group them, which allows me to move all of them at once. I could also, and again, I don't want to select in the group, I could disable them, which will turn them off, or I could turn off their preview. So now they won't preview no matter what happens. So I can select it, and it still, actually it will still preview, but that's only when you have the single selection on. Otherwise, it will only preview the things that aren't hidden. So that's kind of the basics of that. And again, so if I have one thing on and I want to make sure it's previewing, I can right click on it individually, and then I can turn its preview on or off. I can also enable or disable it. So disabling it, it will look like this. It will go gray. It's no longer functional. It doesn't have any output. Everything before it in this chain still has an output, but this particular component does not anymore. So I'm going to turn the, now it's enabled again. So another thing to note, so with nothing selected, I press the middle mouse button, which is my scroll wheel. If you don't have one of those, that is a good question. I will have to get back to you. Hopefully I'll know by the time we start the actual assignments on how to deal with that if you don't have a middle mouse button. With Rhino, it's definitely advantageous to have a multi-button mouse. As I'm sure you're aware, if you've tried doing any modeling using a trackpad, it is difficult, if not near impossible. And 3 buttons is certainly going to be very useful. I actually have a fancy vertical mouse, which helps my wrist, but that's a whole nother thing. However, if I click that middle button, and it brings up another menu, and there's only one thing that I really want to cover here right now, which is this disable solver button, which is a little lock here. Essentially what that does is it will stop all calculations in Grasshopper. So it's a good thing to do if you know you might do something that could crash Grasshopper. You can turn this on, and then you can kind of plug things in and nothing will happen. There are specific times where that will be very useful for you. So these nodes here are connected by wires, which are these either dashed lines you see here or solid lines. Dashes and solid lines mean separate things. It essentially means whether data is grafted or not, which is a confusing term that I will go over more specifically as we are creating this stuff. These wires can be connected to any of these sort of white nodes on each module. So if I were to create a new module, double-clicking anywhere on the canvas will allow you to start searching for modules. So in this case, I knew I wanted a divide curve module, so if I type in divide and hit enter, it'll come up. So if you hover over the letters on either side, it'll tell you what it's either looking for or what its output will be. So in this case, if I'm hovering over the C, it tells me it's looking for a curve. If I hover over the number, it's looking for a count. In this case, it's dividing, so how many times does it want it to count? And then the last one here is kinks, which I Don't exactly know what that means, but that's okay. Sometimes there's some weird terminology going on. But in this case, so it would want a curve, so I could plug a curve in there. And I want to input a number into the end slot. So I'm just going to double click to open up the search bar again. And this time I'm just going to type a number, type 11, and it'll give me a slider, which will allow me to output a number. Any number here that I can just drag into my number. Now my solver is currently locked, as you can see here by that little lock. To unlock, I'm just going to, again, center click here and go down to the enable solver. Again, I'll try to find a way to accomplish the same thing that doesn't involve a middle mouse button, but I'll have that for the next video. So essentially, we can input different numbers here. So this is essentially just dividing that curve. And the higher the number, the more that curve gets divided. It's sort of the simplest operation. But the other thing, so as I mentioned, this is based on a curve that's just a curve that I drew in Rhino. If I start manipulating this curve in Rhino, say I start dragging points around, everything in Grasshopper is going to adapt to it. And that's the real power of a scripting language like this. Decisions you make early on are not decisions you have to stick with. So if you decided that that was your sort of input curve, well, you can still make adjustments to that, even at the very last moment, and still get an output from it. So you can see here that now this is crazy tubular structure. And I can continue editing things. So maybe I decided I want it to be even crazier looking. And maybe I want to adjust how many of those lines I end up having. All of it remains editable at all times, which is the real power of a scripting language like this. It also allows you to do things that are either more complex than would be reasonable or feasible for someone to do themselves, or completely impossible. I mean, I could model this skyscraper here. Maybe it would take me a little while to do it manually. However, doing this in Grasshopper took maybe 2 to 3 minutes for me to do. And again, of course, I'm used to Grasshopper at this point, but that sort of process becomes very easy once you start understanding how it works. So you can generate lots of stuff very quickly. And this Grasshopper is developed created using a particular curve that I drew on the ground. I could adjust that curve, but I could also entirely replace that curve. I believe this is the, so now this one's a little bit slower to move, so if I do things, it's going to take it a couple seconds to actually update, but I can adjust the way my skyscraper looks in real time. I could also, instead of using that default curve that I have, I could switch it to, maybe I wanted to try out a more orthogonal construction. In which case, and again, I'm going to go through this particular definition at a later time, but you can see here, again, I can try out a lot of things really quickly, so there's very fast iteration as part of this process. Okay, so I think that's probably all I'm going to cover for now. There are, of course, a lot of things about Grasshopper. It is a fairly complex software, but as long as you follow along with the steps that I show, you should be able to complete the assignment without too much difficulty. All right, well, thank you guys.